Today's lesson is going to be about the transitive and the substitution property, which are fairly similar and related to a concept that you guys should know well, which is substitution, right? We substitute a lot of times numbers in for variables. So if we look at just these situations below, it says if A is congruent to B and B is congruent to C, then what can we conclude? Well, if they're congruent to the same angle, then that means that A must be congruent to angle C. Okay, and then if we look at the next example, it says A is congruent to B, C is congruent to D, and C is congruent to B. So that's kind of a lot going on there. What can we conclude? Well, if B is congruent to C, then you can just replace one of these, right? And make this angle B. And now you have both of these are congruent to angle B, so that means that these two must be congruent. Angle A is congruent to angle D. Okay. And then finally, if angle 1 is complementary to angle 2 and 2 is congruent to 3, then what can we conclude? Well, if 2 is congruent to 3, then that means angle 1 must also be complementary to angle 3. All we did was take angle 3 and substitute it in for angle 2. And notice how I used the word there, substitution. So basically, the transitive property states that if segments or angles are congruent to the same segment or angle, then the segments or angles are congruent. Okay. So we can apply that back up here, right? So if segments or angles are congruent to the same segment or angle, so A and C are congruent to angle B, which is the same angle, then that means A and C must be congruent. Okay. Here we apply the transitive property twice. Okay, so C is congruent to B, so I replaced one of these. Basically, I used the substitution actually on that one. So I substituted B in for C, and then I use the transitive property, angle B, therefore A and D must be congruent. And then this last one, I use substitution. Okay, now some of you might be asking, well, what's the difference between substitution and transitive? So substitution is literally replacing. So notice how in example 2, I replaced the C with B. I replaced it. The transitive is I made a connection that these two were congruent. Okay. All right. So the rest of today's lesson is just going to be practicing proofs. So in all of these situations, if you want to, and maybe practice the proof on your own. So like hit pause on the video, practice the proof, and then go back and check your answers and see how you guys did. Okay, that'd be actually a really good idea. All right, so we know that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So right off the get-go, notice that we can apply the transitive property. I'm making a connection that angle 1 is congruent to angle 3. Okay. So far, I have angle 1 is congruent to angle 2. And then I also have that angle 1 is congruent to angle 3. So all of these are congruent so far. What I'm trying to prove is that angle 4 is congruent to angle 5. So looking at my diagram, is there some information that I can use? Well, I can see that angle 3 and angle 5 and angle 1 and angle 4 form a linear pair. And we can say that's assumed from the diagram. Okay. Well, what do we know about linear pairs? Well, 1, that they're adjacent, and 2, that they are supplementary. So angles 1 and angle 4 and angle 3 and angle 5 are supplementary. And how do we know that? If angles form a linear pair, then they are supplementary. Okay, so where am I going with all this? I'm trying to prove that 4 and 5 are congruent. Okay, and we have the supplement congruence theorem that states that if angles are supplementary to congruent angles, then the angles are congruent. So we know that 1 and 4 and 3 and 5 are supplementary. And then if you go back to step number 2, we said that angles 1 and 3 were congruent. So 4 and 5 are supplementary to congruent angles. Therefore, angle 4 must be congruent to angle 5. So if angles are supplementary to congruent angles, then the angles are congruent. Okay. Now, sometimes I know the hardest part is trying to figure out where to go, meaning, you know, I have this information, how do I prove it? Okay. So I saw that I had linear pairs. I knew I had a supplementary congruence theorem, and I knew I could use the transitive properties. And sometimes, you know, you're going to start these proofs and you're going to go, you know, you're going to try them and you're not going to get it and you have to erase them. Okay, and that's okay though. All right, let's go to the next example. So lots of given information to start the example. So let's write all these down. Okay, so we know that angle C is congruent to angle ABD, and we know that F is congruent to DBC, and we know that DB bisects angle ABC. So we're going to start off right there because there's a piece of information that we can break down further. If angle ABC is bisected, then that means angle ABD is congruent to angle DBC. So if a ray bisects an angle, then it divides the angle into two congruent parts. Okay, So where do we go from there? Well, now we know that ABD is congruent to DBC. So I'm going to go ahead and erase the one arc because now these are all congruent. And of course, it's not letting me erase. So we're going to mark these with 2 then so that they're all the same. Okay. So we can go ahead and use our transitive property to continue to make connections because we want to get our information down to angles C and B. So angle F is congruent to angle ABD. How did we get that? Well, F is congruent to DBC and DBC is congruent to ABD. So make the connection. Angle F is congruent to angle ABD. This is by the transitive. I can also say that now angle C is congruent to angle F. How did I get that? Again, by the transitive property. Because angle F is congruent to angle ABD. Notice ABD is right here, and that's congruent to C. So make the connection. And actually, I didn't even have to do this step. I could have gone ahead and written angle C is congruent to angle F, and then over here by the transitive, written my whole connection, which was that we went from ABD to DBC, then DBC to F, and then F to C, which I know sounds really confusing, which is why I broke it down into 2 separate transitive properties. All right, and then step 5, we can go ahead and say angle F is an acute angle. Because if angles have the same measure, or if they're congruent, they're going to have the same measure, which means angle F has an acute angle. All right. Now our next example is actually pretty quick. You'll like this one. Oops, on the next page. So we know that angle 4 is congruent to angle 6. That's a given. Okay. And, you got to think, what is the diagram showing me? The diagram isn't showing you linear pairs like it did in the first example we did. The diagram is showing you vertical angles. Well, is there some information you know about vertical angles? Well, hopefully there is. That angle 4 is congruent to angle 5 because vertical angles are congruent. Well, my whole goal was to prove that 6 was congruent to 5, and notice that they're congruent at the same angle, so make the connection. Angle 5 is congruent to angle 6 by the transitive property. And you're done with that proof already. Okay. All right. Last proof. Woohoo! All right, so the given. AD, line AD, is perpendicular to line BE. Okay. So if it's giving you that something's perpendicular, then you're probably going to be working with some form of right angles. And we're trying to prove that angle 1 is complementary to angle 3. So I want to look over here and see, okay, well 3 and 4 are in this corner, and if they're perpendicular, then this means that this forms a right angle. But I have to say that first. So angle BGD is a right angle. Now technically I could have listed 4 right angles, right? All 4 corners, but I'm only going to be working with BGD here, so that's why I only listed that one. So if 2 lines are perpendicular, then they form right angles. Okay, and now since angle BGD is made up of angle 3 and 4, we're going to go ahead and just start using that now. So angle 3 and angle 4 are complementary. Why are they complementary? Well, if angles form right angles, then they are complementary. Why can we say that? Well, remember that complementary adds up to 90 degrees. So if it's a right angle, then they're complementary. All right, so we're getting closer. So now we've worked with angles 3 and 4, but we still need to incorporate angle 1 somehow. So how do we do that? We'll look at your diagram. 1 has a relationship with angle 4. That is, they are vertical angles. And what do we know about vertical angles? They're congruent. So vertical angles are congruent. So now we've used angle 1 and angle 4 and angle 3. And my goal was to prove angle 1 is complementary to angle 3, which I can do now. So angle 1 is complementary to angle 3, and the reason being is the substitution property. Alrighty, that concludes today's lesson. As always, thanks for tuning in.